I will be talking about the Tidyverse. And so the question is, what is the Tidyverse? And I like to say it's a lifestyle embodied in a collection of R packages. So really, the Tidyverse is 6 core packages. And it's kind of funny, they have this graphic here, but I don't even think these are the core ones. These are just 6 packages from the Tidyverse. But the whole point of the Tidyverse is that it's a common representation or design of functions that are always striving toward this principle of being tidy. Tidy has an actual meaning and definition, and we can go into that later, but these functions are inside of all these packages are meant to work together in a way that it's consistent and easily readable. So when you perform your analysis, it's going to be performed in a similar way all the time, and other people can read it easily too and do the same sort of thing. So it really is a big step, I think, in terms of moving R into a place where it's easy to reproduce what other people are doing and do work quickly. So just more practically, the Tidyverse, one, it syncs package versions and warns of compatibility. So if you've ever had a bunch of R packages installed in your computer and they don't work because they're out of sync with versions and dependencies and things like that, that's a real pain. The Tidyverse, it's one package. You do install packages Tidyverse, library Tidyverse, and everything's all in sync. So you're going to prevent a lot of heartache around just your packages not being together. It runs fast, so a lot of the functions themselves are actually written in C++ code so that it'll just be faster when you run it, and that's not a bad thing. And then it's got a lot of smarter defaults. So I don't know if you're an avid R user, you probably know that if you do read CSV and it's got text in it, it turns the column into a factor, and factors are annoying. So these packages have a lot smarter defaults, so you don't have to do that kind of stuff. There's maybe another one that you're always doing. If you ever do write.csv and you write it and it's got those row names off to the side in your Excel spreadsheet after you open it up, it's like, what are these row names, right? It's going to by default not include that kind of stuff. So as I mentioned before, it's really these 6 core packages. So when you do library Tidyverse, it's going to load all of these packages. It's not going to load all the Tidyverse packages, which I think is about 20. It's only going to load these 6. The other packages are just really more niche or specific functionality. So like Haven is a package that helps you read SAS, SPSS, some other files that are just non-traditional. Read XL is obviously Excel files. HTTR will help you do APIs and HTTP calls. So like there's a whole set of Tidyverse packages that are for importing data. There's a lot for manipulating data for strings, and also Lubridate for dates, and then specific set for modeling data with modeler or Broom.
So you'd have to load these packages separately to use one of their functions?
So like if you do install that package Tidyverse, or you do update.packages Tidyverse, you'll get all of these and they'll all be in sync. But if you do library Tidyverse, you'll only get these 6. Unless you realize, oh, I want to use modeler, I want to use Broom, then you'll have to do library modeler, library Broom. So they're included.
Bundled in the Tidyverse. So
yeah.
Tidyverse, you basically use the fixed version.
Yeah, that they all sort of, that's kind of the point, is that so they all are compatible. So one thing as sort of alluding to is that the purpose of the Tidyverse is to reduce sort of your confusion about different packages and how to do things. Something that should be pretty simple, right, is you want to left join 2 data frames. There's a ton of ways to do it and a ton of packages that can help you do it. If you use reshape2, there's this function called merge, and you give it df1 and df2, and you say join by column A1 and by A2 in that other data frame, and make sure that all of the elements of X are true. It's really complicated. You have to really understand what merge is doing to realize that it's just doing a left join. The data table package, it's really fast. You have to set keys on each one of these data tables, but you can join it with just the one data frame or data table with the other data table. The only problem with this is it doesn't really adhere to some of the tidy principles of being human readable and consistent. Like if you were just to swap these or transpose them, it would mean a whole different thing, and you wouldn't really even know the difference. So kind of you've gone from really verbose and confusing to even more confusing by oversimplification. And so tidy, our dplyr package, which is part of the Tidyverse, has left join, which is data frame 1, 2, and then the columns that you want to join on. So it's more, it's similar to SQL syntax, and it's It's just probably the right amount of verboseness, right? It's Goldilocks. It's not too hot, it's not too cold. So that helps with one thing. The other thing is that, again, I'm mentioning is that it's going to reduce some of your confusion between packages that you have in your computer. If you know plier was written before dplier, and a lot of the functions and functionality of plier is repeated, but in a better way in dplier. And if you were to load these packages, the newer one before the older one, it's going to tell you, all, you're likely to cause problems. If you need functions from both, you need to load them in a different order. And it's like, if I don't know anything about R and I just want to do some analysis, why am I even messing with this stuff? Like, I just want something that is quickly reproducible and consistent. And so that's what the Tidyverse helps to do, is get around some of that package confusion. So what does basically the word tidy mean? And that's actually 3 rules compose and make what a data set tidy. One is that the variables are in columns, the observations are in rows, and each one of the cells in the rows and columns is a value. And Hadley submitted a paper in the Journal of Statistical Software called Tidy Data, and I have the link in the presentation, where he goes into a lot more detail about just the theory of these principles that make it, what makes a data set tidy. And really, in essence, the reason for having data rectangular like this is it's just more intuitive for a lot of statistical functions to operate on a rectangular shape, and there's not a lot of guessing if it is non-rectangular. So what do? Do you fill in some of the gaps? Or so it's just really getting into a format which everyone can be comfortable with, and that happens to be rectangular. So an example of tidying data, this is a real-life example. Let's say you have a data set here, and you've got a column called country, and it's got Asia, China, Europe, Germany, Africa, Kenya, and it's got these years across the top and some numbers in the middle, and the numbers don't really mean anything. Let's just say it means GDP or something weird. What's strange about this is it's not tidy, because the column headers are values. They're not variable names, right? The column means something. So if you're ever dealing with a data set and you realize that you might have to group by the year or group by one of the columns based on the name, you want to get that value out of it, that's like a dead giveaway right there. Your data set's not tidy, and you probably need to fix it. The other is, you might notice in the first column it says country, but there's actually multiple variables stored in this one column. So this is the continent, and then this is the country on the continent. And so if you ever have data where you've got basically information jammed together, you again can't do anything with it. It's locked in there unless you pull it back out and make sure that there are separate columns for each variable. So the Tidyverse makes it pretty simple. If you have this data set and then you pipe it over to gather, gather means collect all this data and make it longer based on without the country, omitting that, leaving it off to the left, and then breaking down this columns into year, and just the value, just call it data, you'll end up with this. And then the second command is separate. So separate country column into continent and country, where now these are 2 columns in and of itself. So now this adheres to the tidy principles because every column is a variable, and it's named as such. Every row is an observation, right? It's a piece of data for a year for a country and a continent. And each one of the cells is an actual piece of information too. This is just the country name for this particular row. So tidying the data unlocks it when you put in this formula to now everything else you can do in the Tidyverse, and that's kind of just sort of the stepping stone, is understanding when you don't have tidy data, how to get it into tidy data, and the functions that are within the Tidyverse will help you do that. Gather and separate are just 2 of many, and I'll go into some more details about different functions.
I got a couple questions.
Yeah, sure. Go ahead.
So the piping function there is just a sequential operator, right? So take what's first, use it as input to what's second,
Yep.
the output of what's second, use it as input to what's third.
Yeah, yeah. I have a slide in 1 or 2 now where I talk a little more about what the pipe does. It just takes the output of the left-hand side and passes it to the first argument of the right-hand side. So then you can basically say this is a data frame that then gets gathered, and then the result of that gets separated. Yeah, yeah. So you can see the logical flow, like I was saying previously, of each step in your pipeline, in your process.
Okay. So my second question is answered on the next slide, so I'll wait for that.
Okay.
And then my third question is, what is the DDL double, what is that?
Oh, so it describes the data type?
Yeah, so I'm not, so the first one, the first three are characters.
Yeah.
But I don't know what a double is. What's that?
Yeah, yeah. So it's just a particular type of number,
Okay.
which has decimal places instead, as opposed to like an integer.
Okay.
So this is another feature of the Tidyverse, is that they have some nice printing, right? Where if you had a data frame and you just typed dat, it would just print the entire thing out and you wouldn't know what it is. Now it's showing you here, here's the dimensions of it, here are the names, here are actually the data types, and gives you a little more information about. So if you know, you can perform operations like mean or, mode or median on a double that you might not be able to on a string, or wouldn't make sense to.
Okay.
So that's just part of the printing that's specific to now. Probably your other question was about tibbles, right? So a tibble is, you've actually seen it before probably. So if you use the dplyr package, you notice there's something called tbl_df. So tibble is just like, if you were to say TBL real fast, like that's tibble. So that's how the word came about. And it's really just a dedicated package for all of those TBL_df features that didn't belong in the dplyr package. So when the dplyr package got written, it made sense to have all this pretty printing and tibbles inside of that. But now it just makes sense. It's its own entity. It's a data structure, not necessarily a manipulation task or anything that would necessarily belong in or dplyr. So it's been sort of abstracted into its own package.
Personalities through data frame.
It's the newer representation of a data frame. Yeah. And it's more actually of what tibbles don't do that makes them different from data frames. So they never create row names, so you don't have those weird row names. And the one reason for that is if you think about tidy principles, row names aren't a column in your data set. So why are they off to the side? They would never be in a tidy data set in their own thing off to the side, right? So there's no row names. When you read data in, yeah?
Does that mean what you would use as a row name is actually a data point in a variable?
It should probably be in a column, yeah. Yeah. And then, so they never change the names of the variables. So if you do read CSV and there's a space in the column names, or there's a character that's not alphanumeric or something, it'll replace it with dots or whatever. So it's not going to do anything like that. It'll read it as is, so that you can be more consistent between what you had and what you got into R. They don't print everything by default. So if you type the whole data frame, it doesn't just like spew out every number possible. And they handle types explicitly, so you're never going to get things like strings into factors and not knowing it and things like that. So
number 3 is good if you don't blow out your console. But
yeah.
I haven't figured out how to make it print how many I want.
Yeah, there's a function. I mean, you might just be able to do it with, well, you wouldn't be able to do it with head because it always stops you at 10.
If I want to look at 50.
Yeah, you have to check !tibble and you'll probably find it.
You can't do like head comma 40?
Yeah.
Because by default it prints
I don't think it works.
to 10. So even if your data set has more than 10 rows, it'll still only print the first 10. But there's an argument you can pass to it.
I just haven't figured out what the right argument is.
Yeah.
And
Okay.
whatever.
What's the function though?
Well, I was talking about head.
Oh, but can you search just !tibble and find? Yeah, there's an argument you can pass to tibble as well to get it to print more if you do need it. All right, so another thing about tibbles is consistency. So in the Tidyverse, we talked about having a consistent API. If you have a data frame and you use the square bracket, sometimes it will return a data frame and sometimes it won't. So if you just check quickly, okay, dfdat is a data frame, that's true. And then I try to get the second column of dfdat, it gives me a list of the numbers and I can check that that's actually a vector. So you're doing your work, and then you think you're dealing with a data frame, and all of a sudden now you're not. And then the problem is maybe you have a function that only works with data frames or vice versa. So, and it's doing this without you even really trying to make this happen, and that's part of the problem with prior to the tidyverse. So with tibbles, they always return another tibble. So if you check, okay, my dat is a tibble, and I try to get the second column of that, it returns a tibble that is only one column wide. And if I just try to get a particular cell, like the second row, second column, that's even a tibble too. So you always know whenever you're subsetting or grabbing elements, you're always going to get a tibble back, and you can always do operations that would work on a tibble on those subsets as well. So that's helpful.
It looks like the default, you can change the default, but there's no function to it.
Is it an option?
Yeah, it's not.
You set it as an option in the top of your script.
Yeah. You have to use print, right?
So back to the pipelines. So just so everyone's on the same footing with what the pipe operator means, is it works across all the Tidyverse packages. And again, it just takes the left-hand side and takes to the first argument on the right-hand side. And this is really important because, again, consistent and human readable, it clearly defines what each step means. So this means create a sequence from 1 to 8, then take the sum of that, which is 36, and then take the square root of it, which is 6. So it's obvious what you're doing there. If you try to do it in any other way, it would probably be a lot more code, and you'd have to spend more time deciphering about what you actually did to get the result. And this is sort of a trivial case. It's not that exciting, but when you start to write more complicated code, this becomes very important. So, yeah, what's up?
There is a print tibble.
There's a print.
Print dot tibble.
Print.tibble. All right, nice. I would recommend, if you're using RStudio, just to click on the data frame in the top right environment part, and then just view it. So here, I'll show you an example like this. So if you have the iris data set, I'll call it Tidyverse. I might need to load the Tidyverse first. Maybe I should do something else. I'll use one of the pre-canned examples. Like if it's big, I would just click over to the side and look at it. Right? There's the cool thing too, like, so because everything's pipeable, you'll notice that I have a command over here that's a view. So when you click that button over there, it runs the command view. But you can just take T, right, and pipe that into view. And then now it pops up over here again.
That's in a different window when I'm done looking at that.
Yeah, it's just a tab as a perspective, and then you can get rid of that. So yeah, I guess I'm kind of bringing that up because if you're trying to look at more than 10, it probably means you need to look at a lot more for some reason. And then the cool thing is once you look at them with view, you can then filter. So I only want to look at stuff that's between 3 and 5 and all that good stuff. So there's a lot more functionality there that you might want to use anyways. So I guess that would be one reason to not worry about that printing stuff. So like here's an example of pipelines where they really become much more powerful when you're trying to show the steps in what you're doing and be explicit about what's happening. So if you want to actually find counts in base R for 2 different columns, like here I'm using the empty cars data set, which is a data set of attributes of so many, I think it's about around 30 cars, how many cylinders the cars have, and then whether or not 0, 1, they're automatic or manual transmission. To find out the count of cars that have 4 cylinders and are manual, you have to do table, and then you'll get this matrix. And you'll notice right away, this isn't tidy, right? Because you've got information in the row names, ain't information in the column names. So right away, that's going to be a lot harder to work with. The Tidyverse style, again, is to take the data set and then pipe it to a function that's obvious what it does. It creates counts based on 2 columns, cylinder and AM. And then it gives you back a data frame that shows you now, right, every variable is in a column. And so you can see for 4 cylinders, 0 for automatic or manual transmission, there's the count of 3. And you can take this and you could filter it more. You could do anything you want. So this, while it's cool, it's one line, it gets you something. This is going to be super hard to then say, well, give me the count of stuff that's only equal to 6 cylinders. There's 7. It's easy, I can do it in my head, but imagine when your data set gets a lot bigger, you want to do 3 variables at a time. Now, what does 3 variables look like? It's this thing stamped out as many times as a 3rd variable exists. It just gets really messy, right? So that's where you start to see, hey, this is easy to read, and it gives me a nice data set that I can use downstream for further operations. So that's you'll keep noticing as I keep running more examples, everything that comes out and that you work with is in a Tibble and it's tidy and all that. So yeah, exactly. So here's an example building on that then gets even a little more complicated and confusing in base R, but is still pretty simple in the Tidyverse. So let's say you want to get the counts, but you only want to find the proportion across the first margin, which means for every cylinder level, the percent that is automatic versus manual. And so here we can see, 27% of 4-cylinder cars are manual and 72% are automatic. Makes sense. The thing is, for someone that's new, that's learning R, or just like trying to read your code real quick to figure out what the logic is, what does prop table mean? What does margin mean? It's confusing. So you go back to the Tidyverse way to do it is that, so you have your data set, and you find the counts, and then you group by cylinder so that you're going to perform the same operation on every cylinder level on 4, 6, and 8. And what you're going to do is you're going to take the sum of all the counts for each group and use that as the denominator with the number for that specific group. And then you get, in the percent of cylinder column that you made, the percentages. So it's pretty cool where I can calculate these within group percentages right within my data frame. I don't have to create a separate data frame or have a special function that has margins and things like that, where if I need to know, what percent of 8-cylinder cars are manual, I can tell right away it's 85 or around 86% with rounding. And you can see that for every possible combination of those 2 columns. And again, if you move just to the 3 columns or 4 columns and you want to group by 2 dimensions, 3 dimensions, it's easy just to add another column in here or a different function. You need to define the weighted average or whatever the case may be. So the pipeline makes it pretty obvious.
The ungroup means you only grouped it in order to do the operation on, and then you're going to ungroup to print it.
Yep. So I guess that's a force of habit that I've had because I've gotten burned by it many times, is that the Tibble keeps that logic of grouping with it for the next operation, assuming you want to keep using those groups. And so if I was to do something next that I didn't actually want grouped,
So it's just a good discipline to
it's a good discipline.
turn it off.
At least I think, yes, every time you use it, turn it off. So then again, it sticks with being explicit about your intent. So I wanted to group by cylinder here, and I wanted to do this operation, and I'm done doing that operation, so I'm going to ungroup it. And then I want to do another operation that maybe has a different grouping, or even maybe the same grouping, and I just want to sort of show. But I'd say almost always you're going to want to ungroup your operations after you're done with them. So the cool thing about pipelines is that they also flow into ggplot. So I've seen in places where people will have a data set and they'll have a plot they want to create, and the plot type needs a special type of data set structure. It needs to be wide or it needs to be long, or if there's something special about creating that plot that it needs data in this format. The thing is, you can keep your data set in its rawest form and specifically just to generate this plot, structure it. So here, I'm going to take that raw, untidy data, gather it, separate it. We've seen those before. Group by year, and then find this column, create it, mutate it, called proportion. It's basically, again, by group the proportion, and then throw it into ggplot, and then let ggplot do its thing. So I can see now, for each of the 3 countries, for each year, the proportion they were of the total sum for that year, and then see how it changes over time. You know, we could see Kenya in 2015 got to be a larger piece of the proportion, while China shrank, and then sort of China got larger again in 2016. So you can have your data set, and you can have your visualization, and you can just have the layer in between that does the transformation that you need, and you don't have to create all these objects that clutter up your workspace. Like, I need this DAT2 that then needs to go to DAT3, that needs to go to DAT4, that then goes into ggplot, right? You can just create it here and use it here, and be done with it. And ggplot2 is, you know, part of the Tidyverse, so it plays well with a lot of the principles, and the plots, the data sets that they need can be structured via the tidy functions. So pipelines are really useful for API data munging. So as more and more data sets become transferred over APIs and web services, you're going to run across examples of data that come across as a list, typically because the XML or JSON that the data is originally presented as over the web service is structured in this way. They don't always come across rectangularly, just because those protocols are structured in something that's not necessarily rectangular. So here's an example of maybe data you would get from an API that has movies in it, where here's one movie, here's a second movie, and a third movie, and each movie has a genre and sales in millions. And so you can see I've got one comedy movie, one romance, and another comedy movie that come back in this API call. The question is how do I format this API data to be tidy? So, and even more so in this example, try to find like the total sales of movies that are in the comedy genre. Even a more complex question. If you think about doing this in base R, you're going to have to go through a lot of stuff that, you know, might not make a lot of sense. And so like you first would have to apply the data frame function to every object in the movie list, and then do call rbind them all together. You can think in your mind of taking the list, converting it to a data frame, stacking them together. Then I'm going to subset out the genre just to be comedy, and then I'm going to take a sum. That's pretty complicated. You have to know what do call means. You have to know what lapply does, and you have to subset it and then sum across the column. It gets to the answer, but it doesn't really adhere to some of the tidy principles we talked about. You could try doing it in plier. So you could do ldply, which is doing the same thing, taking a list, converting it to a data frame, then ddply, which is for every genre, creating a summary of sales, which is the sum of the sales, and then subsetting it out to get this. That's interesting too, but it's kind of complicated and would probably vary a lot depending on what you're trying to do. In a Tidyverse, it's pretty simple. You've got a list. You're going to map a function that returns a data frame. So map this list to the data frame function to get these all back, then filter out comedy, and then summarize by summing the sales to get the total sales. So these are 3 examples, one with base R, one with plier, one with dplyr in the Tidyverse. And I would hope it seems simpler to do the last one, because that should be really the lesson here. So you could go from data that's pretty, you know, ugly looking and non-tidy, and then in a few steps get it down in a way that it is tidy and is very readable for someone who's coming back to your code later.
So if you just wanted to look at that tidier version, you would just stop after the map.df line.
Exactly, yeah. I mean, that's the beautiful thing about the pipeline too, is just pick it up to whatever pipe you want to evaluate to, and that's it. And you can see the different steps. So there's a function in that last example that might be new to some people, and that's called the map function. So map is the Tidyverse equivalent to any of the star apply functions like lapply, sapply, vapply, mapply. in base R, and then all of the **apply functions in the plier package. So that's ldply, ddply, llply. There's like all these functions that they're applying a function to something, and map is supposed to be a simpler way to say take something and then just walk through the inputs through that function, supplying the inputs to the function, and then the various output types can be returned. So if I'm going to map something, it's just going to return the transformed input of that function. Map_df will do that function but return a data frame. Map LGL, which stands for logical. Map char returns a character. Map int returns an integer. So you can just say map this function and return this type. So you can be very specific about what you're getting back from those functions. You know, if I use mapdf, it means I'm going to run this function on every input, and I'm going to get a data frame back. They're all going to be data frames back. And that's kind of what was happening here, right, is that I'm taking the movie list, and I'm turning them all those lists into individual data frames, and I'm going to then make sure that I get a data frame back. So I know exactly what I'm getting. And that's what's happening with the map function. So that's really the new thing in the Tidyverse, that maybe if you've been using R already, it's hard to get away from lapply and ldply. If you've been using it previously, it works, you know it, but it doesn't hurt to learn something new that's a little more straightforward. So that's the map function. Now the cool thing about the Tidyverse is that even your models can be quote-unquote tidy. So there's this function library broom, which is part of the Tidyverse, and here I'm explicitly calling the library, because if I did library Tidyverse, I wouldn't be able to run the functions in broom until I run library. I'm just fitting a simple linear regression of horsepower on MPG for the cars data set, and if I just run tidy on that, I get a data, I think it's a tibble actually, or a data frame, I'm not sure which, that has all of the statistics for the model fit that would be sort of stuck out in an object of the model. Now that's gotten us back to where every, again, column is a variable and every row is an observation, where every row now here is a coefficient. It's a parameter of the model, and these are the different estimates and standard errors and statistics. The base R way is if you have this model, you'd have to call a summary on the model and then pull out the R² value. There's this library, model R, which you can just say R² of this model, and you'll get it back. So there's not a huge savings in terms of like lines of code or even readability. This is pretty readable. But as it gets more complicated, like you're piping these functions through, that's the power. Because if you need to compute the R² across 20 different combinations of models, you're going to want to do it with this way, this pipeable, rather than the other way, and then you hand code out maybe 20 different variations of the models and things like that. So here's an example that I was thinking of, is that, so if you know, based on the previous slide, that regression you built, that horsepower has a statistically significant relationship with miles per gallon, you know with the p-value and this t statistic that this thing is significant. But what if you couldn't actually compute that test statistic or the p-value and to know that it actually is significant? So one way you can test for significance is to bootstrap these estimates. And so the cool thing about Broom and Model R is it makes it really simple to do modeling tasks that maybe would be really complicated, like bootstrap sampling or cross-validation. If you've ever hand-coded in R, like a cross-validation routine, it's painful. You have to write out which seeds, random seeds you want to use, and then you got to actually create subsets of the data and do it in a loop or do it in apply. It's really complicated. Here, with Model R, you can just say bootstrap. So I'm going to bootstrap empty cars 100 times, and then I'm going to take the map function, right, and take that bootstrap sample and fit the model on it and return back the model, and then map the tidy function to make the model tidy, and then I'm going to map double, which is saying figure out for each model the coefficient for horsepower and the estimate of it and return it as a double here, and then take the quantile estimates of the around the second and the 97th quantiles to find out the 95% confidence interval. And you'll notice that the 95% confidence interval doesn't contain 0, which is like a statistical test, right? For the significance of a coefficient is whether or not it equals 0. And you can tell, based on our bootstrap of 100 samples, the coefficient never goes positive or anywhere near 0. So you can tell that, yes, horsepower has a statistically significant negative relationship to miles per gallon, which makes sense. The more horsepower your car has, probably the heavier it is, the bigger the engine, it has less fuel efficiency. So, you know, you could see in, what is this, around like 5 calls or functions, 5, 6 function calls, you can do a pretty sophisticated routine in a way where it's pretty simple what I was trying to do, is especially if you understand what sort of the nuances behind what you're trying to do statistically. I think that's a caveat where the functions make sense, but you still have to know what exactly my intent is to fit 100 models on bootstrap samples and then get the estimates and find quantiles of them and things like that. So you're not going to understand everything you read now just because someone's using Tidyverse. Do you have a question? No. So here's another example is, so let's say somebody wants you, instead of fitting one big regression model with other variables in it, to fit separate regressions for each subset or each slice of the data. It's pretty common where people think, well, there's so many interactions within each subgroup, or I don't trust having them one big model. Smaller models are generally better. It's pretty easy to just, again, take your data set, split it by cylinder, map the modeling function, linear model, on it, tidy it up, and then arrange it by the terms. So you can see for every cylinder level in the data set, 4, 6, 8, I have the intercept and I have the horsepower estimate. And because this is in a data frame now, it's pretty easy to do math and do more calculation around, well, what's the difference between the intercepts between 4, 6, and 8 cylinders? You know, it's roughly about 15 miles per gallon and then 2 miles per gallon. So there's a huge change between 4 and 6, but not that much between 6 and 8. And you can do your math on the data frame instead of trying to like fit the model, do a summary of the model, copy paste the value, maybe put it somewhere else, right? You can keep it all as part of a pipeline and then do your math through there. So I think some people would think, oh, the Tidyverse is about just doing data munging and organizing data and doing simple calculations where I'm going to find the mean or find a count or something. But when you think about the perspective of doing things in a tidy way, you could do any operation in a way that's easy to follow, regardless of how complicated some of the math or the statistical nuances might be. So the examples I have in the slide deck are all part of these. This is sort of where I got my inspiration for doing all the examples and my own experiences and things like that. So I would recommend, if you're interested in learning more, check out all of these resources.
So R for data science, does that specifically talk about Tidyverse as a package?
So R for data science is a lot more broad than just the Tidyverse.
Right. Does it include that explicitly?
It's utilized in there and talks quite a bit about parts of it explicitly and how they fit together. I don't know if it's ever been like a, here's the whole thing, but it shows up very frequently. Recoding columns dealing with strings, or dealing with factors, which uses the forecast package, or tidying in data principally what it means. I mean, it's all there, just not all focused on that. And I think that's my last slide. So I said, welcome to the Tidyverse lifestyle. So you can feel like you're part of the lifestyle now that the Tidyverse embodies.